Hey y'all, welcome to lesson 5.4, I think. Um, anyway, it is all about percent composition, but before we get into that, I want to talk about chemical formulas and just give you some information about what a chemical formula is, some different ways to write it, and things like that. So we will start with glucose. That's the name of the compound that we're going to use to do these definitions. It should be one that you are familiar with from biology class. Um, so you should have a little bit of a basis of what glucose is. There are a couple of different ways we can write chemical formulas. The first way is called the molecular formula. And the molecular formula represents all of the atoms, all of them, that are found in a compound's molecule. So it lists in shorthand form all of the compounds or all of the elements found in a molecule. Um, it's a pretty standard one that you see written out. So for glucose, you'll recognize this. It is C6H12O6. That's the chemical formula, molecular formula for glucose. It's got 6 carbons, 12 hydrogens, and 6 oxygens. That's what that means. These little subscripts just tell you how many. 6 carbons, 12 hydrogens, 6 oxygens. We can also write glucose as what's called a ball and stick drawing. You see why it's called that? Because there are balls and sticks. Um, the balls represent each of the different elements, and the sticks represent the bonds between them. So this is what glucose looks like kind of drawn out. You can see there are 1, 2, 3, 4, 5, 6 carbons, 1, 2, 3, 4, 5, 6 oxygens. And if you counted them, you would see there are 12 hydrogens. The ball and stick drawing shows also the way in which those elements are all arranged, or the atoms are all arranged. You can see these are arranged in a circle with some of the other ones just branching off from that circle. But that's what glucose looks like in a ball and stick drawing. Of course, the name we've already talked about. The empirical formula for glucose. So the empirical formula is basically, like it says here, it's the whole number ratio of each type of atom. So kind of like relates in math to like the lowest common multiple or least common denominator. Oh, I don't know those math terms. But you'll see what I mean in a minute. In fact, let me tell you what the empirical formula for glucose is, and that way we can go from there. It'll make more sense. So if we look at the molecular formula for glucose, we got 6, 12, 6, right? The least common multiple, lowest common denominator, whatever, for these three numbers is 6, right? So basically what the empirical formula does is we're reducing this number just like you would reduce a fraction, right? So I'm going to take each of these subscripts, divide them by the least common multiple. Anyway, 6, right? So the empirical formula would be 6 divided by 6 is 1. So C. 12 divided by 6 is 2. So H2. And then 6 divided by 6 is 1. Oh. So the empirical formula for glucose is CH2O. Right? Because we basically reduced these numbers as if they were fractions. Right? So we reduced them. So we get is the smallest whole number ratio. Now, sometimes the molecular and empirical formula are the same. Example for that is water, right? I'm going to start with the molecular formula for water. We all know is H2O, right? Well, the least common multiple of 2 and 1 is 1, right? So the empirical formula is the same, H2O, because it can't be reduced any further. CO2 is also the same thing, carbon dioxide, as CO2. right? I mean, there's nothing I can do. The empirical and molecular formulas are the same. Get another one. Trying to think of a good one. Anyway, we can do C4H8. Right. This can be reduced, right? Because 4 and 8 are both divisible by 4. So I can reduce that down to CH2. 4 divided by 4 is 1. 8 divided by 4 is 2. So that's how you make the empirical formula. The last type of formula we want to look at here is the structural formula. And that's what this is right here. It basically gives the structure and the bonds of the atom. Okay. So here's the structural formula for glucose. You see the 6 carbons, the 6 oxygens, and the 12 hydrogens. But it's kind of written out in a little bit different form than this ball and stick, which is more like a cartoon drawing. And this is more just kind of straightforward. All right. So those are the different types of ways we can draw molecules or write them out. So let's get on and talk about percent composition really quickly here. Okay. So the percent composition is a way to describe a compound and what it's made of, right? It's actually one of 2 ways that gets done. The first way we just talked about, that molecular formula, which writes them out. Formula, like it says here, describes the number of atoms and which type they are, right? Or we can also do what is called the mass percent composition. And that tells us by weight or by mass how much. So think of our glucose, right? How much of it is carbon by weight? How much of it is hydrogen? How much of it is oxygen? Because each of those 3 things weigh differently, right? Hydrogen is a lot less mass than carbon or oxygen. So what percent of glucose is made up of hydrogen? Things like that. So the way we calculate mass percent is by using this formula here. Is 100 times the mass of the element divided by the mass of the compound. Both of these numbers come straight from the periodic table. The mass of the compound, you have to add all the different elements together. But that's how you figure out mass percent. Okay, so let's do a quick example. So we're going to calculate the mass percent of carbon, hydrogen, and oxygen in acetic acid, which is just vinegar, C2H4O2. We'll use this one instead of glucose because it's a bit smaller, less math, right? All right, so we need to figure out the mass percent. First thing we do, step 1, calculate the molar mass and the mass of each element. That comes straight from the periodic table, right? So if we look at our formula, we have 2 carbons, we have 4 hydrogens, we have 2 oxygens. So if we look at the periodic table, the mass of a mole of carbon is 12.01. So we're going to do 2, because there's 2 of them, times 12.01. And then for hydrogen, there are 4 of them. And you look on the periodic table, it's 1.01. And then for oxygen, which there are 2 of them, it's basically 16. And really, if you wanted to for these, for ease of math, let's just round them up to whole numbers. So 2 carbons is 2 times 12, which is 24. 4 hydrogens, 4 times 1 is 4. 2 oxygens, 2 times 16 is 32. Add these all up, and we get 60 grams per mole. So this is the total. This is the mass of the compound. Mass of compound. So that's step 1. Figure out the mass of the compound. Then step 2, we just use this formula up here that we just learned to figure out the mass percent of each part. So let's start with carbon. So the mass of the element we said was 12, but there are 2 of them. We don't want to do that math again. So the total mass was 24 divided by 60, and then all of that mess times 100. And we get, let me grab my calculator, 24 divided by 60 times 100. 40. So 40%. So vinegar or acetic acid is 40% carbon. Then let's do hydrogen. We have 4 divided by 60, and this whole mess times 100. And it's basically 6.7%. So acetic acid is 6.7% hydrogen. And then lastly, the oxygen, which was 32 divided by 60, and that whole mess times 100 to get percent. And we get 53.3%. So this is the percent composition of all the parts of acetic acid. It's 40% carbon, it's 6.7% hydrogen, and 53.3% oxygen. So basically, if you just use this formula, you can figure out the percent of each of the pieces in any compound.